This video will cover the concepts of density and pressure. Our learning objectives include knowing and using the relationships for density, mass over volume, and pressure, force over area. For regular solids, you can measure the volume. For example, for a rectangular prism, volume is width times length times height. For a cylinder, volume is pi times radius squared times height. For irregular solids, the volume is measured by the change in water level in a measuring cylinder for a smaller solid, or by the volume of water displaced for a larger solid. Volume units are important for calculations. 1 cubic meter is equivalent to 1 million cubic centimeters. Also, 1 cubic centimeter, or cc, is the same as 1 milliliter. Density, represented by the Greek letter rho, is defined as mass divided by volume. Mass is measured in kilograms, volume in cubic meters, and density in kilograms per cubic meter. The density formula triangle can help you remember the relationships. It shows that mass equals density times volume, and volume equals mass divided by density. To convert between units, note that 1,000 kilograms per cubic meter is the same as 1 gram per cc. This is derived from the conversion of mass and volume units. Density values vary widely, from the extremely low density of interstellar space to the incredibly high densities of a neutron star and a black hole. Now, let's solve a practice question. Calculate the density of a metal block of volume 0.20 cubic meters and mass 600 kilograms. Using the formula, density equals mass over volume. Substitute the values. 600 kilograms divided by 0.20 cubic meters. The density of the metal is 3,000 kilograms per cubic meter. Here is question 2. Calculate the mass of a block of wood of volume 0.050 cubic meters and density 600 kilograms per cubic meter. We rearrange the density formula to find mass. Mass equals density times volume. Multiply 600 kilograms per cubic meter by 0.050 cubic meters. The mass of the wood is 30 kilograms. Question 3. Calculate the volume of a liquid of mass 45 kilograms and density 900 kilograms per cubic meter. Rearrange the formula to volume equals mass divided by density. Dividing 45 kilograms by 900 kilograms per cubic meter gives a volume of 0.05 cubic meters. For question 4, calculate the density of a small stone in grams per cc. The water level increased from 20.0 to 27.5 milliliters, and the stone's mass is 60 grams. The volume of the stone is the difference in water level, 27.5 minus 20.0 milliliters, which is 7.5 cubic centimeters. Density equals mass over volume. So 60 grams divided by 7.5 cubic centimeters equals 8.0 grams per cc. Question 5 asks to calculate the density in grams per cc and kilograms per cubic meter of a metal cylinder with a radius of 2 centimeters, height of 3 centimeters, and mass of 400 grams. First, calculate the volume of the cylinder. Pi times radius squared times height, which is 37.7 cubic centimeters. Then, divide the mass, 400 grams, by the volume. The density is 10.6 grams per cc, or 10,600 kilograms per cubic meter. Question 6 asks to calculate the mass of a teaspoonful, 1 cubic centimeter, of a neutron star, given its density is 1.0 times 10 to the 17 kilograms per cubic meter. Convert 1 cubic centimeter to cubic meters, which is 0.000001 cubic meters. Rearrange the density formula to mass equals density times volume. The mass is 1.0 times 10 to the 11 kilograms, which is 100 million tons. Next, let's complete a fill-in-the-gaps activity based on the content of the video. Here is the word selection for the activity. The correct words are mass, volume, cubic, 1,000, water, density, displaced, and measuring. Now let's look at pressure, represented by the letter pages. Pressure is defined as force over area. The units are newtons for force, square meters for area, and pascals for pressure. The pressure formula can be rearranged to find force or area. Force equals pressure times area, and area equals force divided by pressure. 1 pascal is the same as 1 newton per square meter. Question 1 for pressure. Calculate the pressure exerted by a force of 200 newtons applied over an area of 4 square meters. Pressure is 200 newtons divided by 4 square meters, which equals 50 pascals. Question 2. Calculate the force exerted by a gas of pressure 150,000 pascals on an object with a surface area of 3 square meters. Rearrange the formula to force equals pressure times area. Multiply 150,000 pascals by 3 square meters. The force is 450,000 newtons. Question 3. Calculate the area that will experience a force of 6,000 newtons from a liquid exerting a pressure of 300 kilopascals. Rearrange to area equals force over pressure. Convert 300 kilopascals to 300,000 pascals. Dividing 6,000 newtons by 300,000 pascals gives an area of 0.02 square meters. This final slide is a quick check of what you've learned about density and pressure. Let's complete this table. Density equals mass over volume. Calculate the missing values for mass, density, and volume in the table provided. Next, let's solve a pressure problem. A metal block with a weight of 900,000 newtons is shown. Calculate the maximum and minimum pressures it can exert on its surfaces. The maximum pressure is 150,000 pascals, calculated using the smallest area of 2 meters by 3 meters. The minimum pressure is 60,000 pascals, using the largest area of 3 meters by 5 meters. Here are several examples illustrating how pressure is affected by force and area. Think about how a change in area impacts the resulting pressure. To calculate the pressure a person exerts on the floor, first weigh the person to find the force. Then, determine the contact area using graph paper and convert it to square meters. Finally, divide force by area. For typical results, with a weight of 500 newtons and an area of 0.006 square meters, the pressure exerted is approximately 83,000 pascals. Off-road vehicles use large tires or tracks to maximize the area of contact with the ground, thereby minimizing the pressure. This prevents the vehicle from sinking into soft ground. A gas exerts pressure because its molecules are in constant random motion. When molecules collide with a surface, they exert a force back on it. Pressure is the total force divided by the area. Other units for pressure include pounds per square inch, or psi, often used for car tires, and inches of mercury, or INHG, commonly found on domestic barometers. The pressure in a liquid or gas at any specific point acts equally in all directions, as illustrated by the arrows shown. Pressure in a liquid or gas also increases with depth, as the weight of the fluid column above increases with depth. The pressure difference equation is pressure difference equals height times density times gravitational field strength, or P equals H times rho times G. Question 1. Calculate the pressure increase at the bottom of a 2-meter deep swimming pool, given the density of water is 1,000 kilograms per cubic meter and G is 10 newtons per kilogram. Using the formula P equals H times RHO times G, multiply 2 meters by 1,000 kilograms per cubic meter by 10 newtons per kilogram. The pressure increase is 20,000 pascals. Question 2 asks for the calculated thickness of the atmosphere required to produce the average sea level pressure of 100 kilopascals, assuming a constant density of 1.3 kilograms per cubic meter.